Today, we're going to balance a chemical equation. The equation we'll be working with is AgNO3 plus NaCl, which yields AgCl plus NaNO3. Let's start with step one, writing down the unbalanced equation. This is our starting point. Now let's move on to step two, listing the number of atoms for each element in the reactants and products. Let's start with the reactants. We have one silver atom, one nitrogen atom, three oxygen atoms, one sodium atom, and one chlorine atom. Now for the products. We again have one silver atom, one nitrogen atom, three oxygen atoms, one sodium atom, and one chlorine atom. Step three is to verify the balancing. Let's compare the number of atoms on each side. We can see that for each element, the number of atoms is the same on both sides. This means our equation is already balanced. Let's understand why this equation is already balanced. In this reaction, we're essentially exchanging the nitrate ion NO3- and the chloride ion Cl- between the silver and sodium. This is an example of a double displacement reaction where the ions simply swap partners. Because we're just rearranging the ions and not changing their quantities, the equation is naturally balanced. So our final balanced equation is the same as our starting equation. AgNO3 plus NaCl yields AgCl plus NaNO3. Remember, in chemistry, a balanced equation is crucial because it reflects the law of conservation of mass. Matter cannot be created or destroyed in a chemical reaction, only rearranged. And that's how we balance a chemical equation. Remember, not all equations will be this straightforward, but the principles remain the same. Always count the atoms on both sides and adjust coefficients as needed to ensure balance. Thanks for watching.